second session is basically looking a little bit at a bigger picture. So what we're looking at now is that we are innovating in various aspects of the cloud, in where we use AI, how we use AI, which data we are using to train AI, where the data comes from. We all look at the edge to cloud continuum. Thank God we don't look at it anymore from a cloud to edge continuum, but we've turned it around. So that's very nice. We understand that the device and the end user are actually more important than the service provider. And my question is a little bit, when we start spreading AI all through the infrastructure and applications, how can we manage the training and deployment of them in a way that it's trustworthy, reliable, because all that AI sitting all across the edge to cloud continuum, who's going to make sure that the traffic lights run the type of AI that you can trust, right? Is there going to be a certification or something like that? So it's amazing what we're building right now, but I'm already thinking at the next question is, how are we going to manage all this, train this? How do we know that the data that is being used is trustworthy to train the AI and all that kind of stuff? So that is basically my question for the next round. And I invite the presenters and speakers to share their opinions, right? So who can I give the floor first? I see some thinking time.
So maybe I can start.
Yes, please.
Okay, so in terms of, as explained in our case, we use AI as, let's say, the key role of optimizing, or let's hope we can optimize this notion of joint data compute network orchestration. So we bring a number of new parameters at different layers to the picture of orchestration, okay, and that also increases complexity. So, and of course, the type of AI we are using, okay, and the data sets that we rely, of course, they are prone to attacks or maybe prone to attacks, etc. So what we are trying to do in Codeco is that we are defining a methodology to analyze the resilience of AI and the governance. So this is a set of checklists, okay, that focus on, in particular, to give to the use cases and later. So right now we are going to release that in June, and that is more focused in our use cases. So we are going to test it in the use cases, which has different categories. So for instance, ethical aspects, so human interaction. So in our case, there is a project, one of the use cases relates with smart cities, and there are so cameras monitoring, okay, so the traffic and so on. And the idea is to do, so let's say the usual offloading in a more clever way. So Codeco gets triggers and does that automatically based on the traffic affluency. And so in that case, for instance, just to give an example, there we may have some personal data, of course. I mean, we are not going to use it, but how should the use case avoid using it or having it? And so what we are creating is, as said, a strategy. So with checklists and steps that each use case needs to follow. So this is one aspect, okay, and the other is, of course, if an attack happens, if a situation happens, then what should we do? So, and this is going to be tested in the project. So right now, I said month 18 is the release of that, and then until the end of the project, so the next 18 months will be used to do validation and to analyze up to which point there is robustness and what happens in terms of governance.
And Rita, is that framework? It's open source, I guess, right? Because it's a pointer to the community. Okay, thank you very much. Very interesting.
So
thank you.
So the report is open. Okay, so will be public in June, but again, that is about the methodology. Okay, so initial tests only, and then Codeco has an experimentation framework that is being set. So where people can not just use the code, but actually do experiments already with additional tools. And we are going also to integrate that. So we don't have that yet, but for instance, for the detection of abnormal patterns, this is something we are integrating. And that is open source.
Okay, so part of the technology is proprietary, I guess. No.
No, everything is open source in Coteco. We really reached a very good point. We managed to convince the large
Nice.
companies, IBM, Siemens, etc. Everybody agreed with an open source, so the code is Apache 2.0 based.
Wow, very nice. Well done. Who would like to comment again on on the question that we talked about? Rutte gave a very interesting already view on how to manage that, but who else in the project is also looking at that?
If I can,
Yeah, sure.
Okay, so regarding for example, the deployment, the training of the AI. So as we said, we have this use case about cybersecurity, where also one of the main pillar of the Cognitive project is to have this secure and trustworthy computing environments, because when also you offload, for example, a function, or you would like to know to use some place where to execute even a function, it could be even an inference engine, it could be an ML inference engine. This should be somehow secure, because we need to understand if there is an attack or if something has changed in the environment. So we have this cybersecurity use case that is looking also how to have this federated learning in secure environments for the anomaly detection of vehicles, automated vehicles, where an attack can be pretty dangerous, right, for the vehicles themselves. Clearly, to make this, let's say, not only secure and trustworthy, but also the question was about fast, light, flexible. We are looking, if we look at this cloud edge or edge cloud continuum, let's say, it's a very highly distributed. So there are a lot of multiple dimensions. So having some centralized approach will not work. Also, if we take into account security and privacy, issue, because we cannot exchange data from one place to another place without considering this secure privacy issue, right? So I think this is a challenge in the sense that from one side, we need to understand how to make this flexible, especially in these highly distributed environments, and then having also tools that allow us to first check if we can trust when we get something back from an inference engine that could be related to a vehicle, could be related to a scheduling a task, and so on. I don't know if that was the question. That's my opinion. So we are looking into these matters also in the Cognit project. I don't know, there was a question from the team, but I don't know, I have to type or I can reply just quickly.
You mean there was another question?
The
energy. Yeah, I was wondering whether it was for your project or for the other project.
I think
I was not sure.
But I don't know if I have to type or I can reply very quickly.
No, you can reply here if you would like. Please also read the question, then I can...
The question was about this kind of energy efficiency heuristic in this project, and I think is about Cognit. So we are looking, so first of all, we have enhanced our monitoring system also with a tool that is an open source tool, Scaphandra, that comes from another project that allow us to measure energy metrics at infrastructure and application level. So this is something that we have integrated in our monitoring system that is also the baseline in order to understand the consumption and having this kind of measures. Clearly, what we are going to do is that the energy efficiency is looked at from the AI orchestrator. So the orchestrator will try to optimize energy consumption using some approach that are called interference-aware scheduling, where we can looking even at other dimension of the workload, like CPU or memory, I/O and I/O disk or network. This is the first approach that we have implemented. It can reduce the energy consumption and so improve the energy efficiency of the system. We are going to look to other approach. This is something that also there is a partner, Umea, that is looking into this, defining this energy-aware task scheduling. But yeah, the main point is the scheduling of the task or the workloads in such a way that according also to the other requirements that can come from an application or from, let's say, the execution of the function, we are looking into this. I hope this... answer what was the question.
Okay. And there's your contact details as well, so they can also contact
in case,
you for more
they can
details,
contact,
of course.
yeah.
Right.
Thank you.
Thank you very much, Marco, to also address that question. So let's go back maybe, to the original question. I see Mark Sanchez. I think you wanted to address that question that we had, right? Or not? No.
What question?
So the question about, how the AI that sits across the edge to cloud continuum, how are we going to manage their, the training and make sure it's trustworthy, and what do we need to do? It's also distributed.
Yeah, in our case, it's distributed because the best strategy we have is like say a kind of federation scenario, because usually our use cases are like contain sensitive data. For instance, one of those use cases is called computer-assisted surgery. So the surgery it's like there is a surgery, the doctors are being assisted by an AI, let's say, and this information that is processing continuously video stream cannot leave the hospital, because you cannot take that data because it's very sensitive and move it around to the cloud. So in that case, the idea is like, okay, we have like you have the cognitive or the learning plane, but the learning plane trains things, but later this is moved and deployed in the edge, and it keeps within the edge boundaries. This is like a typical scenario. Other scenarios could be like part that is sensitive could be kept within the edge. We can, using again some preprocessing with AI, we can summarize the inputs to make it trustworthy, and these inputs could be moved to the learning plane. That could be, for instance, running a model or training a model in the cloud. But the thing is that data is filtered in the same place where it's coming from. So we don't have like taking data, moving around, and then, okay, maybe it's not trustworthy or not, because if they provide us good input, of course, the decision maker could be bad, but this could be the guilty of the original use case. So
do you have then a complete audit trail of your data, of your AI model when it got revised, new training data on it, etc.? So it's auditable. So in terms of when something goes wrong, we can find out who is liable, right? Or not?
Yeah, exactly. Because if the data is not being provided correctly, the learning plane probably would detect this, because we will have like anomaly detection, and we'll notify again people from the edge that you have this AI is not working properly because you are providing input that deviates too much from the input that we have in the past. So we can detect it because we have like this kind of federated model. Let's say that's part in the edge and this part, for instance, running also in the cloud. So
are you also abstracting, let's say, some standard to a standard for an audit trail of AI training, for example? I mean, is there something of a higher level learning that you can feed back to the community and that others can also start using in order to make their AI more auditable?
Oh, yeah. Okay. Yeah, we are working on that, because this is something that is managed by, we are from URB, there is another, and it's Barcelona Supercomputing Center is managing this, but it's like trying to develop an API using what they call data connectors. And with data connectors, they're collecting data, they move it theoretically to the cloud or another place where there is the training being performed. And the idea is that provide an API that people can ask for recommendations. So, and the idea is try to make it, I don't know, more a standard that API, but it's something that we are ongoing. We don't have still well-defined the API. So, but all the project software is again open source. So as like the Codeco project. So when we have this well developed, probably in the next half of the project, people can leverage it and use the different models, how to request recommendations and all the stuff.
Very nice. Thank you. Hui, I thought you were responding to the question. You intended to respond to the question as well. So how do we manage the AI and the trustworthiness and the training? What do you do in your project to kind of facilitate that?
Yeah, we can probably provide a complementary view on this. In our project, we consider explanation or explainability as a part of the trustworthiness. Of course, it doesn't solve the problem once for all. We still need a mechanism to, it doesn't avoid AI from making critical mistakes. But in some situations, the fact that we know why AI makes certain decisions and we can make it to explain why and how they make decision will help us as humans to understand what they are doing. And this kind of a common understanding is a way towards building the trust or building the alignment. An example would,
yeah, could you give an example how you capture that explainability and how you then can certify or qualify it? Because explainability is great, but if
yeah, that's a good question. We have some now. We just have some ideas, not a complete solution, but we are looking at two directions. One is the traceability. When the AI models are making some decisions, they must use some knowledge about either the historical performance of the system or some domain knowledge that they obtain. They either obtain from outside or they learn by themselves. So we want to find a way to force the AI to make the trace about what knowledge they used when they make the decisions. And the problem is that when you start collecting these traces, you will immediately get a lot of data, like logs or a huge amount of knowledge. So then we think that the generative AI could be helpful here if you provide this huge amount of data to them. And then the human stakeholders can start to query what exactly was the explanation. And this can be used based on this retrieval augmented generation. So based on your query, the large language model can generate the data processing or the data extraction queries among this huge amount of traces in order to generate a more human understandable explanation about what was happening beneath the AI made decisions.
Yeah.
So that's one direction. And the other direction is that we want to be able to create some challenges to the AI, especially to those AI that we use as a black box, like the large language model. It generates things, but we don't know how they generate these particular things. But the way we can do is to create some relevant questions to ask back to the generative AI. And if we can, by getting the answers of these relevant questions, we can be able to make a knowledge graph about how the AI managed to reach these kind of decisions. I have a simple example which is not relevant to computing continuum, but it's often used as an example about this. Let's say if we ask which country is Obama from, then the large language model may answer you that he's from the US, but there is no trace about what was the logic chain for it to reach this example. There must be some knowledge that it used, but we don't know which knowledge it used. We can ask similar questions like, what is Obama doing? He can probably say that he's the president of the United States. And then we can further ask, what is the relation between this job and the country? So by asking these relevant questions, then we can start to build an overview about how the AI made the conclusion. Yeah. So that's an open question about how you generate these questions and how you link the questions and answers together. So it's still open question to us.
Yeah, absolutely. And just as a teaser question, do you think that LLMs will become, let's say, smart enough when they're being tested? For example, I remember the diesel scandal in Europe, where the software was basically able to recognize when the car was being tested and would, self-tune itself. Do you think, that is possible, no, to build that in AI as well?
Yeah, I don't have any conclusion. I can only guess.
It will always be a cat and mouse game, I think.
Yes, yes. When you're getting more and more, you're getting smarter, it also learn to lie. That's something that we probably couldn't avoid.
Yeah,
But
exactly.
But it's the same like we build the trust between humans. We know we kind of assume that the human may lie, but at the same time we have strategies to create or to build the strategic conversations that can avoid this or even somehow build the trust regardless whether they would lie or not. I don't have a clear answer about how this can be done, but there are research in this direction.
Yeah. So maybe it was another project that was not, we didn't have time to present it here in the webinar, but we're also part of a number of projects. And one of the projects is called ACES, where we use a swarm intelligence to basically orchestrate not only the composable infrastructure, hardware on the edge, but also do the orchestration of the workloads. And we put swarm intelligence first, and we use AI ML to try to understand the swarm, why it is behaving in a certain way, and how that relates to the parameter settings. And we hope, but we can tell you also only in a year and a half from now, whether it's possible actually to have certain metrics installed that allows you to understand how you can actually influence the swarm behavior in a way that the platform becomes energy efficient, has good bandwidth, etc. But it's a complex question. Yeah. But what I find interesting in the answers I heard so far, and that I would like to highlight, is actually now that we're developing so much AI, and I think what is beautiful to see is that we are looking really at building digital sovereignty, right? We look at distributed infrastructures, multi-tenancy, data from multiple sources, AI provided by various developers and organizations. Then the question is, okay, so but what are the rules in order to make this trustworthy? And I hear already in some of the projects we're looking at those aspects, and maybe I'm jumping the gun for the session that after 12 and 4 minutes, but one of the answers could be future projects should focus on that. So what are the rules and tools of the game in order to feed your AI or share your data in the digital sovereign economy in order to make it trustworthy, right? So maybe we should start doing something there. But okay, before we go to that session, we still have a couple of minutes. Is there anything you still want to share on let's say, AI training, model management, data management in your projects?
Just to let you know that there are some speakers with their hands raised to speak. For example, Alexandros Nizamis.
I see it now. Sorry. Hi.
Good.
Alexandros, go ahead,
Yes,
please.
I would like just to elaborate a bit more with what we said. For example, as he refers to explainable AI, I think is a nice way that can support a lot regarding the transparency part if we're checking from Trustworthy AI. For example, in the project, what we're thinking to see is to try to present to developers or system administrators, etc., to present why some decision was done in this AI orchestrations that we have discussed so far. So in the end, which are the features that the AI orchestrator finally considers for training and for taking this decision. So we would like to see if really the energy consumption features was really taken into consideration, or if in the end we just go again only for the performance. So I think this type of the information is a type of the information that we would like to collect and present. There are a lot of libraries related to explainable AI that they do this, and the idea is to try to incorporate some of them and use them for supporting this transparency part of Trustworthy AI. But also, as other people comment here, it's not only thinking for transparency. If we want to trust AI, also we should consider that AI will be always available, should be reliable, and so on. So I think we should also consider approaches, as we said, about federated learning that support both on privacy, but maybe also in the performance. Also, we can break down somehow complex AI systems to smaller ones for having some more flexible deployments. So all this containerization and microservices logic that I see in all projects, I think also apply if we want to have AI to be available and lightweight and so on. Maybe we should consider other techniques such as transfer learning, so we can use already pre-trained models from one case to another. This is near to federated approach, but it's not exactly the same. And I think also we should consider this part and not only the transparency part that we mainly discuss. So that was just a comment in addition to what we and other people said for me.
Perfect. Thank you, Alexandros.